Hello, my name is Lara Castaño, and this is my analysis to the Lab 1 of Physics 2211. To get started, the main objective of the experiment was to observe an object moving at a constant velocity and compare the experimental values with a computational model. In this case, a starter code takes the initial conditions of the motion of the object and predicts the expected outputs of the experiment. It is important to understand the main physics principles involved. The experiment revolves around the first two Newton's law of motion, the first one being the law of inertia that states that an object in motion will remain in motion and an object in rest will remain in rest unless acted upon an unbalanced force. Additionally, Newton's second law states that an object is in constant velocity if the sum of forces acting upon it, an object is zero, meaning that the net force equals to zero. And as the momentum principle states, when the net force is zero, the momentum will continue constantly, and as a result, the object will continue moving at a constant velocity. Here it is shown some relevant formulas and calculations. Um, the velocity update and position update formulas are very important for closed scripts to predict the position of the object. It will utilize the initial conditions coordinating tracker and use these code statements shown here. With the values coordinating tracker, I was able to calculate the initial velocity and the initial position. Okay, now we're going to analyze the object in motion in tracker. The object I chose was a alcohol spray bottle that is pushed alongside the edge of a whiteboard. So first, I set the frame limit at the bottom and set the center of the spray bottle. And I wanted to track the bottle frame by frame following this straight line. So we're going to see the motion. If we observe the upper right limit here, we can see the graph of the position of the ball as a function of time with the data points shown below. The graph resulted in a linear negative sloping line, and the reason behind this is that, as we can observe, the bottle is moving from right to left. So it's moving towards the negative x-axis. And that's the reason why we have a graph with a negative velocity. As it can be seen, I changed the object's mass, and added the initial conditions, and also I changed the while loop to end before the end time of the observed motion. And when I run this program, it can be shown that if the object follows a similar path to the stray bottle, going to the negative x-axis, and the resulting position and time values in closed script were then analyzed alongside the values obtained experimentally in a spreadsheet. In the Excel sheet, I plotted the data of both the position versus time of the observed model and the predicted model and created a graph. And it can be observed that both lines have a negative slope due that they move from right to left. And we can notice that both have a start having almost an identical position. But as we can see, neither line starts at zero, which is expected because the object's motion starts being analyzed after some time the bottle started moving. Looking at the graph, um, the the predicted line is perfectly linear, but the observed graph isn't, as it has some small curves. As time progresses, the slope of the observed motion flattens, indicating a decrease in the velocity of the object. And I think the reason behind this is that I didn't take into account the friction force that was acted in the opposite direction of the object, which caused the velocity to slow down. So what if we have flipped the x-axis? I don't think nothing would have happened because the graph would have resulted in the first quadrant with a positive slope, meaning that the velocity would have been positive. And the only thing that would have changed would have been the direction, now that the right side is the negative one, but the magnitude of the velocity would have remained the same. So the only thing that would have changed was the direction of the velocity. So what does it mean? I don't think it is possible to say how many pushes and pulls were present to make the net force equal to zero because there were forces that we didn't consider. We didn't know that the normal and gravitational force were present, but we didn't take into account the friction force. And so we did know that all the forces that acted upon the object made them equal to zero, but we didn't know how many forces were involved. So we don't know the exact number of pushes and pulls present.